Today we're going to talk about something called the zero product property. Okay, it's a really important concept, the zero product property. All right, and before I tell you exactly what that is, I would like you to think about these two questions. All right, first question. If we know that A times B is equal to 16, what do we know about A and B? And the second question, if we know that C times D is equal to 0, what do we know about C and D? All right, go ahead and pause and just write down some thoughts about these two questions. What do we know about A, B, C, and D? Okay, pause and do that. Welcome back. All right, well, let's think about the first one. If we know that A times B is equal to 16, what do we know about A and B? Right? Or more specifically, could we figure out what A and B are? Right? And the answer is not really, because there's so many possibilities. Right? Maybe A is 1 and B is 16. Right? Or maybe A is 2 and B is 8. Or maybe A is 4 and B is 4. Right? Those would all work. Right? We don't know which one of those is right. Or maybe A is 0.25 and B is 64. That would work as well. Or maybe A is equal to -3 and B is equal to -16/3. Right? That would also work. All right, so basically, what do we really know? If all we know is this, that A times B is equal to 16, what do we really know about A and B? And the answer is we really don't know anything. Right? All we know is that they multiply to get 16, but we don't really know what A and B are. Now, what about the second one? If we know that C times D is equal to 0, what do we know about C and D? Right? Well, we don't know exactly what both of those numbers are because, well, for example, C could be 3 and D could be 0. That would work. Or C could be 0 and D could be 125. Or C could be 0 and D could be 137/4. Right? We don't know exactly what C and D are, but there is something that we do know. Right? We do know that at least one of those, C or D, has to be equal to 0. Either C is equal to 0 or D is equal to 0, right? Because it has to be. If we have two numbers here that multiply and the answer is 0, well, at least one of those two things, C or D, has to be 0. So even though we don't know at this point what C or D is, we know at least one of them has to be 0. All right, and that's basically the zero product property. Here is it stated formally. Right? It says, the zero product property says, if the product of two or more factors is 0, then at least one of those factors must equal 0. Right? If we have a product of two or more factors, and that's equal to 0, then we know that at least one of those factors must equal 0. Right? Another way to write it is you could write it symbolically. We could say, if we know that A times B is equal to 0, right? And you could change that and make A times B times C, or A times B times C times D equals 0. It doesn't matter, right? If we know that A times B is equal to 0, right, then what do we know? Right? Then one of those two factors has to be equal to 0. In other words, either A is equal to 0 or B is equal to 0, right? Or possibly both, A and B are equal to 0. Right? That's what the zero product property says. If we've got a multiplication problem that has the answer of 0, well, what do we know? At least one of the factors has to be 0. All right, we're going to use that idea of the zero product property to solve some equations. All right, so let's think about this one. All right, we don't know at this point exactly what x is, but what does this equation tell us? This equation tells us that these two factors, this factor x minus 2, right, this is one factor, times this factor, x plus 8. X minus 2 times x plus 8 is equal to 0. Right? Well, let's think about what the zero product property says. It says that if we have a multiplication problem that has an answer of 0, right, then one of these two things has to be 0. Right? In other words, right, we don't know right off the bat exactly what x is, but in order for this to be true, either this, x minus 2, has to be 0, or x plus 8 has to be 0. So then we could write this. Either x minus 2 could be equal to 0, or we could conclude that x plus 8 could be equal to 0. Right? And let's think about that. When would this be true? When would x minus 2 equals 0 be true? Well, the only way that's true is if x were 2. Right? And you could solve that equation, right? I could add 2 to both sides here, right? And we'd get x equals 2. Right? Well, what about the other one? When would x plus 8 be equal to 0? Well, the only way that would be true is if x were equal to negative 8. Right? And I could show that by solving. I could subtract 8 on both sides and get x equals negative 8. Okay, so the two solutions are these, 2 and negative 8. Right? So we could write x equals 2, or the other value for x could be negative 8. Right? And let's just pause and think about what that means, right, for this to be our answer. Right? When we're saying that we've solved this equation and this is our answer, we're saying that these are the possible numbers that would make this true. Right? And let's check, see if that would work. Well, would it work if x were 2? Well, if x were 2, all right, let me write this off to the side here. Right, if x were 2, right, would this be true? X minus 2 times x plus 8 equals 0. If x were 2, right, then this would be 2 minus 2 times 2 plus 8 equals 0. In other words, 0 times 10 equals 0. And yeah, that's true. Right, what about if x were negative 8? Would this still be true? Right, if x were negative 8, this would be negative 8 minus 2, and this would be negative 8 plus 8 is equal to 0. Right, negative 8 minus 2, that's negative 10. So negative 10 times negative 8 plus 8 is 0. Negative 10 times 0, that's 0. Yeah, that's true. 0 equals 0. Okay, so those are the two solutions, right? 2 and negative 8. And why are those the two solutions? Because 2 is the number that makes this factor 0, and 0 times, well, whatever this is, would be 0. And negative 8 is the number that makes the second factor 0. Negative 8, if I plug it in here, negative 8 plus 8 is 0. 0 times whatever this is would be 0. Right? We can do this for even bigger ones, too. Let's take a look at this one. X, the quantity, x minus 4 times x plus 5 times x plus 6 equals 0. Right? Well, let's think about this. Right? Again, we've got a multiplication problem equal to 0. What does the zero product property tell us? Well, it tells us that if I have a multiplication problem where something times something times something is equal to 0, the only way that this is going to be true is if one of these things is equal to 0. Right? So in other words, it's possible that x minus 4 could be equal to 0, x plus 5 could be equal to 0, or x plus 6 could be equal to 0. Right? Well, let's think about each of these individual cases. When would x minus 4 be equal to 0? Well, that would be true. If I add 4 here, I could see that that would be true if x were 4. The second one, when would that be true? That would be true if x were equal to negative 5. Right? And I can show the work there, and you can probably do this one real quick. Right? When would x plus 6 equal to 0? Well, that would be true. If I subtract 6 from both sides, you can see that that would be true if x were equal to negative 6. Okay? So in this case, there are three answers. X could either be equal to 4, or x could be equal to negative 5, or x could be equal to negative 6. Right? And it's important to put that or there, because remember, what are we saying? We're saying that these are the possible things that x could be equal to. These are the numbers that would make this equation true. Right? So x could either be 4, negative 5, or negative 6. I'm going to do one more example, and then you're going to try some. Okay, so this one, we have 2x times x minus 6 equals 0. Right? And I want you to think about it this way. Right? What do we have here? We have the number 2, or a factor of 2, being multiplied times a factor of x, times a factor of x minus 6, and that's equal to 0. Right? Well, what does the zero product property tell us when we have a multiplication problem equal to 0? It tells us that the only way that this could be true is if one of these three things is equal to 0, right? One of these three things has to be equal to 0 in order for this multiplication problem to come out to be 0. So in other words, either 2 could be equal to 0, x could be equal to 0, or x minus 6 could be equal to 0. Now, wait a minute. Let's think about all those different cases that I just wrote down. Do they make sense? Does this one make sense? Does that make sense to say 2 equals 0? And of course it doesn't. So we can just ignore this. That obviously can't be true, right? The zero product property tells us that one of these three things has to be equal to 0. Obviously it's not 2, because 2 is 2. So we could narrow it down and say, well, that means either x is 0 or x minus 6 is equal to 0. Right? And this one, we basically already have an answer, right? X could be 0. Or what about the third one? Well, if I add 6 here, I could see that x could be equal to 6. All right? So in this case, there are two answers. X could either be equal to 0 or x could be equal to 6. Right? Those are the numbers, 0 and 6 are the numbers that would make this true. All right, now time has come for you to do some of these on your own. All right, please pause and solve this one. All right, let's see what you got. All right, so we've got 4 factors here. These 4 things multiply to equal 0. Zero product property says, if this is true, one of these 4 things has to be 0. So either 3 is equal to 0, or x plus 4 is equal to 0, or x minus 2 is equal to 0, or x plus 1 is equal to 0. Right? Do all of these make sense? No, 3 can't be equal to 0. That doesn't make any sense. So in order for this to be true, well, I know 3 is not equal to 0, but one of these 3 things has to be equal to 0. Okay? The solutions that you should have gotten, right? Well, I'll just go ahead and do them real fast. If I subtract 4 here from both sides, I get x equals negative 4. In the second equation, if I add 2, or as I guess you call this the third one, if I add 2 here, we get x equals 2. If I subtract 1 here, we get x equals negative 1. So there are 3 answers. X could either be equal to negative 4, or x could be equal to 2, or x could be equal to negative 1. All right, try this one. Please pause and do this one. All right, so this one we've got 4x times negative x plus 5 equal to 0, right? All right, we've got 3 things here. 4 times an x times negative x plus 5 equals 0. Zero product property, again, says if these 3 things multiply to 0, one of them has to be 0. So, is it 4? Could 4 be equal to 0? Nah, that doesn't make sense. Right? How about x? Yeah, x could be equal to 0. Hey, there's one answer already. And then the third one, this one's the interesting one. The negative x plus 5 could be equal to 0. Well, let's make sure we can solve this one. I would subtract 5 from both sides, and I get negative x equals negative 5. What does that mean? Right? That means, well, if I divide both sides by negative 1, I get x equals positive 5. Right? So that means that this original statement is going to be true when x is either equal to 0 or x is equal to positive 5. Right? Those are the 2 numbers that make that true. Last one. Okay, so again, please pause and try this on your own. All right, thanks for doing that on your own. And if you didn't do that on your own, shame on you. All right, so we have 3 factors here, right? We've got 5 times 2x minus 1 times x plus 4 equal to 0. All right, again, zero product property says that if this statement is true, right, then one of these 3 things has to be equal to 0. Right? Could it be 5? Could 5 equal 0? No, that doesn't make sense. 2x minus 1 could be equal to 0. X plus 4 could be equal to 0. The x plus 4 is the obvious one. When is that going to be true? Right? When x is equal to negative 4. Right? So if I subtract 4, we would get x equals negative 4. All right, this one. When would this be true? Let's solve it. I'm going to add 1 to both sides. I get 2x equals 1. And then lastly, if I divide both sides by 2, I would get x is equal to 1/2. Right? So, when is our original statement true? Well, it's true when x is equal to 1/2, or if x is equal to negative 4. Right? And lastly, I just want to double check. Does that make sense? Does that make sense for the 1/2 and negative 4 to be my answers? Well, let's think about it. If x were 1/2, and I plug it in here. 2 times a half would be 1, and then 1 minus 1 would be 0. So 5 times 0 times whatever this is, 5 times 0 times whatever is 0. That makes sense. How about if x were negative 4? Well, right here, negative 4 plus 4 would be 0, and again, 0 times whatever this is 0. So those make sense. Those are our two solutions.